Find the angle generated by P in 8 seconds. So here's the picture. Here is ray OP, and assume that it's on a circle. Let's do this correctly this time. Draw a circle. Okay, let's see. Not the way I wanted to do it. All right, never mind. So this thing sweeps sweeps some sort of a circle, like that. Okay, like it rotates. We don't know if it's counterclockwise or clockwise, but it rotates. All right. Now the speed that it's moving, what's called the angular speed, with pi over 12 radians per second. So if you just do like a units conversion thing, pi over 12 radians per second times 8 seconds tells you how many radians have been swept by this thing. So it's 8 pi over 12 radians. Is that okay so far?
Yeah.
And we don't we would let's say we wanted to convert this to degrees to kind of know how many degrees this is, because radians don't mean much to us. There are to do this, you multiply by 180 over pi, convert it to degrees.
Mhm.
So the pi's cancel. And if you're not allowed to use a calculator, which you may not be, 180 divided by 12 is 15. 8 times 15 is 120. This ends up being 120 degrees. That's 90. So it ends up sweeping something like this, 120 degrees, like that. If you were to use the radians, you'd want to reduce this to 2 pi over 3 radians.
Okay.
All right. Any questions on that before we do part B?
Uh, no, that makes sense.
Okay. So what you should keep in mind is that you're on a circle. There's only a couple of things you can calculate on a circle. One is the angle. One is this distance here. Right? This distance here. We did a lot of these problems the other night. That's what this problem is asking you. It's saying basically like, okay, we've got a circle with radius 60 centimeters. And you know that this angle is 120 degrees, or you can use 2 pi r, 2 pi over 3. We want the s, the arc length. That 8 seconds just refers to the previous problem where we calculated how big of an angle was swept. So if it said like 6 seconds, we'd have to recalculate the angle. That makes sense?
Oh, yeah.
Okay, so the arc length is s equals r theta. What do you remember that's super important about theta? What's the requirement of the angle in this formula?
The requirement of theta.
Yeah, the angle. There's something really important about the angle that you have to remember right here. So the angle has to be in radians.
Oh, okay.
It's really important. Like you can, oh, 60 times 120. No, that's terrible. Cannot do that. You have to use the radians. So it's 60 times 2 pi over 3, which ends up being 40 pi centimeters. Now, why is it units of centimeters in this problem? What are we calculating?
The distance.
The distance, yes. And distance or a length is in centimeters. So there we have it.
Okay. That makes sense.
Okay. Now, did you guys, for part C, did you get any formulas for linear speed, angular speed, anything like that?
We got linear velocity and then
Yeah,
angular
that's the
velocity.
same thing. What do you
Yeah.
what do you have for that?
V equals RW
Okay,
and
so
then
V equals, yeah, W times R, RW, actually it's RW, that's how it's usually done, R times W, okay?
for linear velocity.
Yes. Okay, so the, I don't want to say this, R is the radius, W is the angular speed in radians per second. So you may see a problem where they don't give you the uh radians per second,
Hmm.
and you'll have to maybe convert.
Okay.
Trying to look at for something. Um, so this is more physics, by the way. I don't know if you've taken physics.
Yeah.
You might remember doing these calculations, but maybe not. So this would have been after Newton's, after momentum. Basically, you relearn all the equations you first learned, but they're in the rotational for things that are spinning. All right, so you have your radius. Your radius is 60 centimeters. Your angular speed was given in the original problem as 8 pi over 12 radians per second. All right, so the speed ends up being 60 pi over 12 or 5 pi centimeters per second.
Where'd you get pi over 12 from?
It was given in the problem. In the Sorry, that's where I was scrolling. I don't know if you guys can see the scrolling, but
Oh, okay.
yeah. Now there is kind of like a, well, what should the units of velocity be? Like the teacher could say, give me the linear velocity in meters per second. And then you might have to convert this. Can you hear the cat?
No.
Okay. You just jumped on me while I was doing the process. Didn't know if you could hear it the whole time. Okay. We can move on to 19 now if you're ready for that.
Yeah.
All right. Not to scale. Okay. Do you have any idea how big like Jupiter is compared to like the Earth, for example?
Like I know it's a lot bigger, but
Yeah. It's like a, like a cat inside a house. It's like
oh.
it's very small. It's really, really, really small. But because it's so far away, we don't actually have a good sense of that. And that's why it says not to scale. I mean, it's not even this close. I mean, and the problem with some of the models is, they're so far away, it's hard to really get a sense of like, what it is. Okay. Um, so it takes Jupiter 11.86 years to complete one orbit around the sun. Let's see the figure. If Jupiter's average distance from the sun is 483 million miles, 800,000 miles, find its orbital speed. Now, a couple things here. Um, this is an approximation. Do you know that the time to travel around the sun is not the same every year? Just like that's why we have a leap year. It's the same for all the planets because they're slightly elliptical. They're not actually circular. They're slightly elliptical. Like they wobble a little bit. And that's why this average distance from the sun is here because it's really not always this distance. Like sometimes a little closer, sometimes a little further away. This is why we have, the seasons and all some of those other things, along with the tilt of the sun, or the tilt of the earth and other things like that. Hopefully those are all things people have told you. It maybe like worrisome, like why wouldn't it be the same? Um, so then the orbital speed is a angle. It's find its orbital speed. That's the angular speed. So that's W. Um that's the angular speed, which is in radians per second. Okay, so more generally though, it's the change in the angle over the change in time. Did you see that in class at all?
Uh, no.
Okay. So uh that's why I'm like, how are you guys supposed to do this? So the time, you know that it goes one revolution. That's this right here in some amount of time. So it's one revolution in 11.86 years. And one
How do we know that
revolution,
this one is angular velocity?
yeah, it's a speed along its orbital path.
So revolution over
Well, it's a good question.
time.
So we're getting slightly outside of my area of expertise because I don't really know why they use these words. I just know to do the calculations. Orbital speed. Okay. To me, that's how fast it's moving in the circular direction. Now, I don't know, maybe it's linear speed, but it says no, you know what? I take that right back. It says miles per second. So you can always use the units to figure that out. So we need W. We need W to find V. I take that back. Always use the units to figure out what you're trying to find. That's a good thing in physics. So we're going to find W and then use W to find V. So here's how we're going to find a W. One revolution around the sun is 11.86 years. We're going to need to convert years to seconds at some point. One revolution, though, is 2 pi r, right? And in this case, what's the radius? It's this horrible number in miles, which is fine. So it's 2 pi 483 123 miles. Okay, so we're in good shape here because we got the right units, but we need to
Wait,
convert
where'd you get
years.
the 2 pi r from?
That's the circumference. One revolution is the circumference.
Okay.
That's a good question because it is. It's like, where does it come from? Um, so what some students do is they start with that, but this is the more kind of general form, which is like the change in the angle. The angle, like this is angle. This is theta equals 0 degrees, and then when it goes all the way around, theta equals 360 degrees, which is one revolution, or 2 pi.
Okay.
Okay, so that's where we're at. We're gonna convert the years. So 1 year is 365 days. 1 day is a lot of seconds. We'll say 24 hours, and 1 hour is 3,600 seconds. Let me clarify that last part because that could be right, so 1 hour is 60 minutes, and 1 minute is 60 seconds. So notice everything cancels except for miles per second, which is what we want eventually. Although I'm still not sure if they want V. This one will have the answer, won't it? Maybe you're muted. Be careful with the calculation. Make sure you multiply all the numbers on top. So the number is sort of manageable. My guess is this is what they want.
$195.06.
I've got a slightly different result. 282 pi. I'm just double checking my numbers. 483, 800,000, 11.86, 365, 24, 6. Excuse me. Please, yeah, please double check your calculation. I got a different result here. Let me sniff the whole thing in.
For the top, I got 303,980,5052.
Okay. So I always do this entire calculation. So let me check the top here. Yeah, that's fine. Times 10 to the ninth, hopefully. For the top. Or maybe yours didn't have it. Because the numbers are so big,
No.
they don't mean much. But yeah, let me snip in all of this. Uh, it's not a bad way to go to do the top and to do the bottom. Let me snip all these calculations in though. And that's why you show your work and this type of problem is that way you know. Do you have the answer? Because I'm pretty sure this is it. Miles per
Um,
second.
one sec.
Yeah.
Yeah, it's 8.127.
Now, so
What
this
did
is
I
V. I'm good.
I think I probably just like messed up multiplying the bottom. Oh, I think I forgot the 24.
Okay. Yeah, that will definitely do it. Now, I made you know, I made a mistake here. Because the the W does not include this R value. And I don't do this for this type of calculation very often. That's why so the W would not include this miles, but you can include it if you're trying to get V because V is W times R. So I don't know if you want me to redo this calculation, but what I should have done is one revolution is 11.86 years times one revolution is 2 pi radians. And then the rest of this would have stayed the same. And so your answer here would have been in radians per second. So let me calculate that. It's a fairly, you know, I don't know, it's not a great number because it doesn't mean much. But you end up getting this number for radians per second. Okay, and that's your W or your angular velocity, and V is W times R. So you would take that number you just calculated times the 483,800,000 miles. Okay. And so what I did, which was incorrect, is I did the calculation together, which you can do, but I didn't do it the way I showed. Like W is really this number, V, which they want, is really uh this number up here. Is that clear?
Do you think you could explain like the whole process of how you got it again? Because I still kind of don't understand.
Okay, sure. Let's just restart here. All right. So why don't you read the problem to yourself one more time and then we'll talk about it.
Because the equation I have, uh,
We'll start from the top down. So top down is the end goal is to find miles per second, which is V. V is W times R. What is the radius in this problem?
wait, how do we know miles per second is V?
It's V is always velocity is always change in position over change in time. So it
Okay,
always has units like meters per second or kilometers per hour or something like that.
okay,
W has units of like revolutions per second, radians per second. It's a
okay,
rotation. Think of think of yourself. Okay, the difference between R and W, maybe that's what's unclear here. R is you walking, W is you spinning.
okay, yeah.
All right. So now our goal. So this is the approach that I use to solve problems is you start with the big equation like V equals W times R. Well, what do I have? Well, I have R. R is 483,800,000. But I don't have W. So now I say, okay, I got to find an equation for W.
What's
W is the
W again?
angular angular speed. It's the speed at which you're spinning. How
Okay.
fast are you spinning? Because when you're walking, you know, okay, I walked a certain amount of distance in a certain amount of time.
Mhm.
Distance per unit time. Spinning is rotations per unit time. Now, if you're just spinning in place, you're not going anywhere. But if you're on a Ferris wheel, have you changed? Well, it depends, right? Depends on where you are, but you're moving continuously in the circle. Like when your tires wear out, why do they wear out? Because they're never moving relative to the car. They're just moving in a circle.
Mm. Okay,
So they wear out because they're spinning.
yeah.
So the angular speed is the change in the angle, the rotation, and the change in time. I use letters. So it's typically one revolution per unit time. Time in this case is 11.96 years. Is that okay? 86 years. One revolution around the sun takes 11.86 years.
Okay, yeah.
All right, now what is a revolution? Well, a revolution is 2 pi radians. That part is 360 degrees. We don't use degrees, we use radians. Okay.
Hmm.
So now it's the conversion from time. 1 year is 365 days. 1 day is 24 hours. 1 hour is 60 minutes. 1 minute is 60 seconds. And so your answer will have units of radians per second. That's this calculation here.
Okay.
This is W. So now once you have W, you're like, okay, to find V, I need W times R. You take the number you just found times um, the R value, 483,800,000. And so your calculator will do the entire calculation. So it's best if you let the calculator do it.
That makes sense. Yeah. Okay.
Can we move on to the next question?
Okay.
20. Number 20.
So the units for this would be miles over second.
All right, let me know we can move on to 20.
And so for questions like these, should I have the unit circle memorized so I know what they mean by 2 pi over 3?
It does help, but it's not necessary because you can always convert. You can always convert, and you don't actually need.
Oh yeah.
So the Ferris wheel problem, classic problem, okay? Um, the person you get on the Ferris wheel down here at the bottom. Okay. Now they're saying though, like consider this your zero. This is 0 degrees. Okay. So
Mhm.
2 pi over 3 radians. If you want kind of a like, where is that? You multiply by 180 over pi. Could you calculate that for us, please?
Yeah. 120.
120 degrees. So this is 90. So it's somewhere there. You know, that's 30 degrees, the whole thing. But that's where you are. You're right there. Okay. Now you could memorize the unit circle, but what we want, here's what we want. We want this distance, and then we also want the red here, which is the same as the radius.
Okay, so we would do SOHCAHTOA.
You could, yeah. The so it does help to know the unit circle, but yeah, if you really don't, or you know, you're not there yet, what you need is 30 degrees. We know that the radius here is 50, so that's also R. Okay, so go ahead and find the well, okay, it depends on your instructor now. It could be a non-calculator problem where you just set everything up, but this is cosine of 30, sorry, sine of 30. Sine of 30 equals h over 50. So h equals 50 sine 30. Sine of 30 is a known value. It's 1/2. So this ends up being 25. And so the distance above the ground,
75.
yeah, is 50 plus 25, which is 75 feet. Now, okay, important thing here. your teacher may add the following to the problem. The Ferris wheel is, I don't know, 6 feet off the ground or something. And the reason that's important is because that adds to the height of the person above the ground. Like you don't get on a Ferris wheel exactly at the ground. You always walk up a little platform with some stairs, the railing, right? You're not like the Ferris wheel appears to be at ground level, but you actually are already above the ground. Do you know what I'm talking about or not?
Yeah.
I can grab a picture if needed. So
No,
what
yeah,
what
but
because your teacher may like add a little bit like that, and it's the same calculation, but you also have to add in 5 or 6, or the height 6 feet above the ground. So in your case, it would be 81 feet.
okay.
I am gonna click pictures. I just feel like this could be really missed. If you look back at the notes, like that's the ground, right? And there's some, you're already like 6 feet off the ground to start. Okay. So now the next question is asking for angular speed or angular velocity. So angular speed, W, W is the change in the angle over the change in time. Okay, so they're saying 2 pi over 3 radians, that's the angle in 30 seconds, like that.
Okay.
And that's it.
So
There's
they
no
gave us
they gave us the rotation, which is the change in the angle, and they gave us the time.
okay.
So it ends up being 2 pi over 90, which is pi over 45 radians per second.
Yep, 2 pi over 90. Oh, 30 times 3. So then it would be pi over
And this is no,
45.
yeah, this is okay. Like this is probably better than anything else you might give.
Okay. And then we'd multiply that by 50.
No, because angular speed is in radians per second. If we wanted the linear speed, W times R, we would take the pi over 45 times the radius, which is 50.
Oh, so angular speed is just W?
Just W, yeah.
Okay. Is there a difference between angular speed and angular velocity?
In your class, no, but in the real world, yes. Um,
Okay.
and the difference comes down to speed versus velocity, which I think is worth a brief discussion of. So speed is what your car you're driving, correct?
Mm-hmm.
Okay. Your car gives you your speed. I don't suggest you doing this, but when you back out of your driveway or you back out somewhere at a your odometer will go up, like, or your speedometer will go up. You'll like see it be like 5, 10 miles per hour, right?
Yeah.
And if you go forward, it says 5, 10 miles per hour. Speed does not care about direction. You know, if you and I are going in the opposite directions down a road, we can have the same speed. Velocity has both what's called magnitude, which is the number, and direction, which means it matters whether you're going, forward or backwards, positive or negative. So speed is just the magnitude. So the relationship is speed equals the absolute value of velocity. Angular speed equals the absolute value of omega. That's the relationship between them. But for you
Okay.
in your course, you're calculating V and W. Okay. What else you got? Do you want me to
Could we
find some
do,
problems or go ahead?
yeah, could we do something similar from like this and last week or the last
Uh,
lesson?
yeah, I mean, we probably only have time to do like one more problem just based on
Yeah,
how
that's
long these
fine.
take. So do you want more like these?
Yeah.
Okay.
And if possible, do you think you can send me more practice questions like these in the last lessons or?
The last lesson really tough. These ones are not too bad to find. And just to be clear, like what I'm doing are just word problems. You just look for word problems. So here's, I'll throw this in the chat. I don't know if you get the chat after the lesson, but you might want to click on those links
Yeah, I don't think I
right
do.
right away. I get it, and I don't want it. So, which I mean, it's really for the students. This one looks okay. Maybe they're the same. Are these the same? No, they're not. Okay. Some have the answer, some don't. Does it have the answers at the bottom? Yeah, it does. Okay. Um, from last week or last time, boy, latitude and longitude. We'll pick a problem there. I'm just looking at one more worksheet to see
Yeah, yeah.
if I could find one that's like those problems. Um, now this is a book. We don't want a book. Oh my gosh. Yeah, one of the issues is that like these problems are more of they're more in the geography space. Um, okay, come on, one more triangle word problems. Navigation. Maybe these are navigation problems. I'm I would just redo the ones that wait, this one has one. Okay. Um yeah, this one has one. Okay. I found one. And the one of the ones I sent you has one of these problems. I guess we can do this. All right, Memphis, Tennessee, and New Orleans, Louisiana lie approximately on the same meridian longitude line. Memphis has a latitude 35 degrees and New Orleans has a latitude 30 degrees. So what I never remember is which one is up and down, which one is so longitudes are vertical and latitudes are horizontal. And there's, some
Yeah.
great images out on the web, which I think are worth, you know, remembering. Here's one that I like. Okay. So they lie on the same meridian, which I don't know what that means, longitude line. So that means they're on the same vertical. So your picture is like this for longitude. It's like the circle is I don't know, I don't know, it's like one's here and one's here, and that's these dots here. Is that okay?
Yeah.
Now, if you're really good with your geography, you might actually know that without, I mean, maybe you got a good picture of the map of the United States, to Tennessee and Louisiana. They're not in the same horizontal. But sometimes you don't know, like, I don't know, Morocco and Florida are on the same latitude. Like, how would I know that? I wouldn't know that. Um, so uh, it also kind of tells you from here, 35 north and 30 north. So what that's saying is like from the horizontal, this isn't going to be drawn well, but it's like saying from the horizontal, one is 35 degrees and one is 30 degrees. So what's the little piece between them? What's the angle between them?
5.
5. Yeah. So when you want to calculate S equals R theta, what is the requirement of theta?
Um, the requirement of the radians.
Yes. The reason I'm testing you on that is like it's such a big one to remember. And I think it's 3963 miles, kilometers. I don't know. You have to look
Yeah.
that up. And then so it's 5 times pi over 180. You have to convert it to radians. This is also kind of a cool picture. I don't know. So, center of the earth, um, these are the longitudes. The latitudes are going around circularly. I don't know, maybe this doesn't help, but that's something to maybe look into. Um, that's it for that problem.
Okay.
Okay, let's see if we can do one more here. We're gonna go a little longer today. Um, I actually like these questions. So, right, this is back to what we were doing. The Earth rotates about its axis once every 23 hours, 56 minutes, and 4 seconds. Right? It's not exactly 24 hours. Breaks the hearts of some people. And the radius of the Earth is 3960. Find the linear speed. Linear speed. So that's V. To find V, you need W and R. Do we know W or R in this problem?
We know we know R.
So we know R is 3,960 miles. We don't know W. W is the change in theta over the change in T. So it's basically like one revolution. How long does one revolution of the Earth take?
23 hours, 56 minutes, and 4 seconds.
Yes. Now we want our final answer in hours. Maybe the clumsiest part of this. So we have 23 hours plus 56 over 60. Is it clear why that converts it to hours?
Yeah.
It's the whole hours, minutes, seconds thing,
Mm-hmm.
plus 4 over 3,600. So that gives you hours down here on the bottom. Now, what is one revolution? Well, it's 2 pi radians. 2 pi radians. So that's your W. Once you get your W, use it with your R. So we get this number and then multiply it by 3960. There's your velocity. If you're looking for problems online, I would look for problems with the solutions. And so the search here is always actually let me just tell you what the search is. If I can find it. Not that. Okay. So this is the search. This is the secret sauce here. You always put in your class the things that you're calculating, worksheet and PDF.
Okay.
And you'll find, first 510 will be all you need. Um, that's what I've been doing to find stuff. The other one I couldn't find really as much of. It's like navigation, latitude, longitude, but that gets you into geography, so it's really tough to find. Um, your problems. Your book will have more problems in the chapter review. Sometimes in the back of the book they have like a post test or second test review
Hmm.
in like in the I don't know what to call it, the appendix will have some books have so that's where the other thing you can do is go to another trigonometry book. So you could search for another trigonometry book online and then do a keyword search for latitude and longitude. Maybe find some more problems.
Okay.
All right. Let me go ahead and stop the recording.